Hello everyone, this is our third lecture for Chapter 6, An Introduction to Probability. In this lecture video, we will discuss the different types of events. There are 4 types of events: independent, dependent, mutually exclusive, and complementary events. Before we talk about different types of events, let's define what is an event. An event is a subset of outcomes from the sample space. In an experiment, an event is the result that we are interested in. The probability of an event A is written as P open parentheses A close parentheses. The first type of events we are going to discuss is independent events. When the outcome of one event does not change or affect the outcome of another event, we call the two events independent. For example, when playing a board game, you need to toss 2 dice to determine how far you move on the game board. The number you roll on the second die is not affected by the number that was rolled on the first die. Another example is the 10 and 30 coin flips you did when we first started talking about probability. Each flip had no effect on subsequent flips. These were independent events. Another example, let's say we have a bowl with 10 red marbles and 10 blue marbles. You pick a red marble. The probability of picking a red marble is 10 out of 20, which is 0.5. Now we put the red marble back in the bowl and pick again. It's a red marble. The probability for the second pick is still 0.5. This is what we call in statistics sampling with replacement. Each pick gets returned so that the probabilities are not changed from one event to the next. The second type of event, sorry about that, my puppies were playing. The second type of events is dependent events. When the outcome of one event does not change or affect the outcome of another event, we call the two events dependent. Let's take our previous example with our bowl of 10 red marbles and 10 blue marbles. You pick a red marble. The probability of picking a red marble is still 0.5. However, this time you don't put the red marble back into the bowl and you pick again. It's a red marble. The probability for the second pick is no longer the same 0.5. It changed because we have a reduced number of red marbles and a reduced total number of marbles. The probability for this second pick is now 9 out of 19, which is 0.47. This is what we call in statistics sampling without replacement. Each pick does not get replaced, so the probabilities change from one event to the next. And the way these probabilities change depends on each pick. Another example would be playing blackjack. The dealer shuffles a deck of cards at the start of each game, deals the cards, and once the play is over, the cards are discarded. The dealer is now shuffling less cards for the second deal, and the probabilities have changed. The deals are dependent events until the dealer takes all of the cards and reshuffles them. So, how can you tell if an event is independent or dependent? Step 1. Ask yourself, is it possible for the events to happen in any order? If no, you're done. It's a dependent event. If yes, or you are unsure, go to step 2. Some examples of events that can clearly be done in any order are tossing a coin and then rolling a die, purchasing a pair of shoes and then purchasing a Happy Meal. Some examples of events that must be performed in a certain order are parking and getting a parking ticket. You can't get a parking ticket without parking. Surveying a group of people and finding out how many of them are for or against gun control. You can't find out how many are for or against gun control without first conducting the survey. Step 2, ask yourself, does one event in any way affect the outcome of the other event? If yes, you're done. It's a dependent event. If no, you're done. It's an independent event. Some examples of events that affect the probability of the next event are choosing a card, not replacing it, then choosing another card. The probability of choosing the first card is 1 out of 52, which is equal to 0.0192. But if you do not replace the card, you are changing the probability to 1 out of 51, which is equal to 0.0196 for the second card. Choosing anything and not replacing it, and then choosing another, like bingo balls, raffle tickets, and so on. Some examples of events that do not affect the probability of the next event are choosing a card and replacing it, then choosing another card. The probability of choosing the first card is again 1 out of 52, which is equal to 0.0192. If you replace that card, the probability of choosing the second card stays the same, 1 out of 52, which is equal to 0.0192. Choosing anything, as long as you put the items back, will not change probabilities. Two events are mutually exclusive if they cannot occur at the same time. Another name for mutually exclusive events is disjoint events. Examples of mutually exclusive events are a coin toss, either heads or tails, whether participants are married, single, divorced, or widowed, whether participants in a controlled experiment are given a placebo or medication, you are either employed or unemployed, whether military personnel are in the Army, Navy, Air Force, Marine Corps, or Coast Guard, you are either a smoker or non-smoker, whether we select a king or queen from a standard deck of cards, class ranking, freshman, sophomore, etc. The key is that the probability of A and B occurring is equal to 0. So the probability of both events happening at the same time is equal to 0. It is often helpful to draw pictures of events. These pictures, called Venn diagrams, represent events as circles. Each circle represents an event. Here you can see that we have two mutually exclusive events, A and B. In this example, one pet cannot be both a dog and a cat at the same time. Two events are not mutually exclusive if they share at least one common outcome. Here you can see that we have two events, A and B. Event A is juniors, and event B is English majors. And we also have a small subset of juniors who are English majors. Another example of not mutually exclusive events is students who are enrolled in statistics class and students who are enrolled in sociology class. There may be students who are taking both statistics and sociology in the same semester. One last type of events is complementary events. We introduced complements at the end of the first video lecture for Chapter 6. Complementary events are two outcomes of a trial that are the only two possible outcomes. Complementary events are usually mutually exclusive. They cannot happen at the same time. Examples of complementary events include the event is having a pet, the complement is not having an event. I'm sorry. The complement is not having a pet. So the event is having a pet, and the complement of the event is not having a pet. A coin toss with one coin. The event is landing on heads. The complement of the event is landing on tails, or the complement of the event is not landing on heads. The event is cars with defective airbags. The complement of the event is cars without defective airbags. One more. The event is rain tomorrow. The complement of the event is no rain tomorrow. Our next video lecture, we will discuss how to calculate probabilities for independent, mutually exclusive, and not mutually exclusive events.